Good morning, engineering 2. Woo! Can you guys hear me? Somebody say yes, maybe. Thumbs up. Yes, okay. Alright, let's start the class by sharing my screen. And then we can discuss what we're gonna do today. Okay, so what we're gonna do today is we are gonna begin talking about dimensioning. You guys have now a little grasp of how your view should look. You understand pictorial views. You understand orthogonal views. You also understand the concept of line weights, center marks, center lines, hidden lines, whole callouts. I believe you guys are ready to start talking about doing dimensioning properly. So pretty much today, what we're going to do is just talk about rules. So when you guys do your next assignment, I don't red mark your paper, and it makes it easy for me. Otherwise, I will have to crazy. So please, when you guys doing your next assignment, show it to me. That way, I don't have to execute your paper. Three-dimensional modeling. Well, as you guys know, we are behind by one lecture, one lab session. So I probably should have started 3D modeling last time we met, but as you know, we are behind. But don't worry, I'm pretty good at catching up. So we're not do the modeling this time. Most likely, we'll start 3D modeling sometime next week, maybe on Tuesday. One thing in your previous homework, the one that we did with CAD, I was looking at it, and it seems to me that I forgot to write through because it's a hole that was on the way through, so you should write through at the end. FYI, if you remember. What else is coming your way? So this deadline change, I changed them last time. So if you go to your canvas, and again, the reason why I changed them is because I wasn't aware that homework number 4 has two parts. That's homework 4A and homework 4B. So if you guys go to your Dropbox, look for that one. And I think I kind of like briefly talked about it yesterday during the lecture, but I want to double check you guys understand that you're gonna do two of them. So I got lab homeworks, and then you guys got homework number 4. And if you guys want to, let me see if I can go review. So I gave you this file, which should give you enough information to be able to do this drawing. You don't need to add the dimensions. You get to put it to 8.5 by 11. When you print it, you need to print it to 1:2 scale, so it actually fits. In fact, in your in the text that you're going to add, you should probably also add the scale. So you should set scale equals 1:2, right? Since you're not doing the title block. Now, if you want to do the title block, because we did it on homework number 5, you guys are welcome to do it. Okay, but not required, because in homework number 4, I did not talk to you guys about layers, block setup, stuff like that. So just make sure that you have this homework 4A, B also part of it. I believe I gave you guys, we did this one, right? But it has to be both of them. Let me see if I give you the, somewhere it has the instruction right there. So I did this one, and you guys gotta do the one on the right side. Let me turn on my pointer focus. You guys can see it better when I'm putting my, okay, so again, you guys need to do this one. I gave you enough information, and I did this one, right? Make sure that when you submit it to me, I think this one is submitted to me electronically, homework number 6, which is going to require you to know about basic dimension. So here is your assignment, homework number 6. And if you go over here, it's telling you measure and sketch. So what you guys are going to do next time we meet next week, if you're caught up, you are going to, I'm going to give you a couple of parts. You are going to grab, I believe, a ruler. It's like you're going to be grabbing a ruler. And then you are going to add some notes on the drawing, seems to me. And then you are going to create one of those parts. So again, I'm going to bring a couple of boxes with these parts. You're going to measure them. And then you're going to create a drawing. And then you are going to add dimensions this time. Now, when you add dimensions, you got to follow my rules. And they're not my rules. They are based on the ASME Y14.5 and other standards that tells you how to communicate your design intent properly, right? It's kind of like a language. So this is what I'm gonna do. When next time we meet, I'm gonna tell you guys which one you guys want me to do, and then we'll do one in class, and then you guys get to the other. Hopefully, the one that I do, you guys are gonna do it correctly, and the other one, since you already had an example, you should get to the other one. We have a large class, so I don't know if I have enough blocks for everybody. So if I don't get to have these ones, then I will give you an additional one. Very good at looking at drawings. I have the eye. Let's take a look at the requirements. So just remember that when you are making a drawing, you are giving instructions for somebody else to build. So you guys are part of the design team. That's why you guys are going for engineering, because you are the design team. You're going to give, you as the designer are going to come up with drawings that will be able to communicate a design intent. And then we'll get, this guy will go to the manufacturing department. I don't know, the manufacturing could be a bunch of people with CNCs, a bunch of welding machines. There might be electronics, whatever that is the case. And then somehow, as you're doing these parts, there will be somebody that has to be checking this. And that will be the inspection department. The inspection that is going to be checking the parts that match the design. So there has to be a connection between the three departments. And that connection is your drawings. And your drawings need to speak the language so manufacturing and inspection can speak the same lingo, right? So the first step to create a good set of drawings is to know how to dimension. And then right after that, after we learn and we grasp how to dimension, most likely we'll start modeling properly, right? And then right after that, then we'll start adding symbols, which are additional language. Hopefully by the end of the class, you will have a good grasp of how a drawing should look by the end. There may be iterations back and forth. Maybe some of the features that you select, that you put in your drawing, it's let me erase this. So what's going to be bugging me? Sorry. Now, once I'm going to have this guy all the time. That focus. Let's go erase there. So if I don't erase there, then it's going to be bugging me. Let's put that erase there. All right. So previously say the drawings, they're not a final product. They're instructions for a final product that might go through a different set of cycles. We call these revisions. And then eventually you'll be able to communicate with inspection and manufacturing, and also as well as other designers. Okay. When you have a drawing, these are the essential drawing requirements. Your drawing should contain all the geometry that is necessary, the orthographic views, and no other isometric view, no others. What do I mean? I mean that if you were to have a part and your part does not require a top view or a side view, you don't need to add it. You just add what is required to communicate your design intent. Let's suppose that I have a piece of sheet metal that looks like this. Alright? See? It's just a piece of sheet metal. It has a thing like this. Do I need a side view? Do I need to go and come over here and put a little line and highlight? I don't think I need it. Why? Because I can call out the thickness of the material. I can say a 1/4 inch plate, 1018 hot rolled steel. I know the material and I know the thickness. Boom, done. Right? Do I need a top view? No. So you will create the views that are necessary to be able to convey your design intent. And it's not my rule. It's the ASME rule. The isometric is optional. Back in the day, it's isometric. You did your isometrics, the one that was on the corner, right? That one. That one is optional. But now that everybody's done it with the models, you guys will want to start doing modeling hopefully next week. Now that we are dealing with the modeling, it is something that has become kind of like standard, not explicitly set on the standards, but everybody puts it there. What I guess it's a little bit, it's easier to see an isometric view. Back in the day, it was optional. Why? Because they used to be done by hand. So now everybody using modeling, they just click on a button. You need to put the dimensions with tolerances. Everything that you build and is going to go through a manufacturing process will have to have a little plus and minus, right? The little plus and minus, say, that will be my region of plus and minus. When I go in, if I dimension and I say, hey, this guy, it is, I don't know, 1 inch. The 1 inch is not going to be exact. I cannot say 1.00000. because in reality somebody needs to cut this. All right, it's my piece of sheet metal, so I need to give it a leeway for manufacturing. This leeway, this wiggly room that allows me to grow or decrease in terms of size, right? Close to 1 inch though. The wiggle room, we call that tolerance. Every drawing should have its tolerance. And in fact, when you go and you do your assignment, somewhere in your assignment, you're going to put some notes. And I did not give you the tolerance, but it should have the tolerance somewhere. Now, when we actually start doing things for real, we're going to start soon, we are going to create drawings and create the models, and we're going to dimension properly. We're going to be learning symbols, and hopefully by the end of the semester, be able to communicate simple design. Everything needs to have tolerance. Either you're going to put it on the notes, you're going to make a note. Let me see if I can split the sheet, and we can have the notes on the side. Have the drawing here, right? You're going to notice here I got the notes, right? So the notes will be part of the general notes, like the ones that are here, or sometimes what they do is this tolerance, you see that, the tolerance, sometimes it's part of the title block, okay? Title block is the bottom when you have a bunch of information. Sometimes they include it as part of the title block. Let me see what else do I have here. You need to add the material. Yes, if you're going to be something, you're going to tell it what it is, right? So yes, put the material. Most likely, what you're going to build, what you're going to do is going to become part of an assembly. If it's an assembly, again, an assembly all it is it's a combination of parts together to have a function. So, for example, here I have an assembly, and this assembly is a couple of parts, and some of them become a welded assembly. So if I pop this one out, pop it out, and then I pop up the springs, pop it up, the one on the bottom is an assembly, and it's part of a weld assembly. See, used to be a pin. I got it welded. And then the pin that is here, it did not get welded. You will see there is no welds at the end of the connection. It's actually a top of it. This is a pin, right? And believe me, I cannot take it. I cannot take it off. This guy over here, this is another. Seems to me this one is welded. Seems to me it's welded, stack welded at the end. This is another assembly. We call this one we call it a low level assembly. We call this a low level assembly. And when do you combine them together? You put a couple more parts if they're required. You put this together and you call this a higher level assembly. This high level assembly can be part of another higher level assembly, right? Again, it's kind of a little bit nomenclature. It depends on really how high of the complexity your assembly is. But again, at the end of the day, the parts that you are making most likely are going to be part of an assembly. Okay, so you need to tell them how many parts do you need. Somewhere in your title block, they should tell you your quantity, which is right there. That's why QTY stands for quantity. You also need to tell it the scale. Nowadays, the scale has been a little bit, let's call it, less used, especially on mechanical engineering drawings. Why? Because many of the models have been now used to convert the models into a G code or M and G codes, which allows you then to convert it into NC code. NC code is the file that you go and you will put in a CNC machine. So this guy has become a little bit less relevant, right? Again, but there are still people that manufacture things by hand, and sometimes you might want to have scale. Now, all of the drawings that we are going to do, and actually all the mechanical drawings, they need to have everything dimensioned. Since everything is dimensioned, there shouldn't be a need for you to go and grab a scale. But for civil drawings, it's typical, and I don't have any scale, but usually the scales, I'm going to assume you've ever seen a scale. The scale looks like a triangle, like that, and then it looks like that, right? And somewhere in the text, somewhere here and somewhere there, we'll have a bunch of graduation somewhere on the side here, somewhere on the side here, and somewhere in here I will tell it can have 3 types of scales. I don't think we'll go over scales in here, but we could have different types of scale. We can have a metric scale, and if it's a metric scale, what's what? I will say metric. We can have an architectural scale, and if it's an architectural scale, I will say architecture. And it can also have an engineering scale. Engineer. And that one would also say that. So there are 3 types of scales. Again, they're really commonly used. Actually, civil engineers are the one that use it very often. Architectural also use it pretty often. You can make drawings also in metric format, right? So you might use that one as well. But for mechanical people, usually we don't use slots that often because all of the dimensions should be on the drawing. However, by standard, we also put the scale all the time. Same thing like the isometric, which is optional, but the scale is not optional. It's actually part of the requirements. You also need to have the surface finish. Surface finish is, well, when you look at the surface, you have manufactured it, right? How grainy is it? How polished is it? Is it going to require a special finish because it's going to be a moving part? It's a nut. You guys will notice that my pin here, it is exposed to motion because this guy is meant to come over here and squeeze, right? So I need to, since it's going to be up and down and up and down, I need a better finish than this one, right? The one over here, this is just going to pretty much to bend a piece of metal. I use this doohickey, I use it for my materials lab, right? It's an assembly that was made for us to do one of our labs. So it just lets you know that sometimes you need different surface finishes depending on the application, depending on the function. You will put that in the drawings and you can put it, remember the notes, let me see what it rates here. Unless otherwise specified, this right here, the one that says FAO, this one, that one's the surface finish. FAO means finish all over. All over. Finish all over. And then it has 125. 125, it is the micro inches. And then we will talk about surface finish later. I just want to let you know you should have it in the drawings. At the beginning, before we talk about it, most likely I'm just going to give you the number. But that is the finish. Allows you to see how things is going to be at the end of the manufacturing process. You also need to let them know if it's going to be on inches or millimeters, right? Maybe you have a metric drawing. If it is metric, it's going to be on millimeters. If it's an imperial inch system, you're going to tell it inches. You also need to let them know the standard. The standard for mechanical people usually does not change that often. This 2009 standard was like a rule in the industry for quite a long time. And I believe last year it changed from 2009 to a 2018 standard. And what year are we on? 2025, right? So you guys will notice how it doesn't change that much. And then the 2018 standard is probably going to run for quite some time. Now, what's the difference with the 2009 and the 2018 standard? It's pretty much the same. If you guys want to take a more advanced class, like the advanced mechanical drafting class that I teach, which if you take it, see the name of the class in case you guys ever want to take it, is offered, I believe, next semester, is Intake 34, and this one is advanced mechanical drafting. And you would pretty much, if you are done with it, you should be able to get certified by the ASME certification, GDTP, right? And in fact, if you guys ever want to know, the student that got them, they got, I think he got silver on regional and he got gold on state, and then he got fifth in the nation. He got his certification from that class, right? So after the class, he went into the class. Right now, he's not here. He went and he transferred to another university, but it's come to tell you that some of these classes are good, especially if that's your branch. You'll be able to put something in your resume. Okay, so you need to have the standard. Again, I'm telling you, the 2009 standard is the one that rules. It rules still. Not a lot of people have changed. Still rules the industry. Okay. Now let's continue here. Let's look at rule of similar dimensioning rules. So we have requirements and we also got rules. Rules, you put in inches, you put your tolerance, you put finish, you put quantity, you put material. You put the views that you need. The isometric is optional. Forget the standard. Okay, so the rules. Give all dimensions necessary to accurately communicate the design and manufacturing personnel, but only those dimensions necessary. You do not dimension like crazy. Okay, and I think that is one of the biggest problems that I get every time I teach this class. You guys just think that you're gonna dimension and you're just gonna go dimension, click there, here, and you go here, and I'm gonna dimension there and there, and then there, and then you put one then here, and no, when your drawing tends to be like a mess. So when you dimension, I'm gonna teach you correctly. Pay attention. You do not dimension like crazy. There are dimensions that you need to apply so you can communicate your design intent, and that's it. Only the dimensions that are necessary. You need to apply the dimensions in such a way that they cannot misinterpret it. I'm going to show you a technique, not right now, it's like with an example, that should allow you to not double dimension, not put dimensions extra, and then put the dimensions where you're supposed to put them so you do not cause misinterpretations. You need to show the dimensions between the surfaces or points that have functional relationship. As you guys remember, as I previously told you, your parts are going to become part of an assembly. Okay? And as being part of an assembly, they have functional relationship between one another. When you apply the dimensions, when you put the dimension is going to be based on functional requirements and functional surfaces. Okay? So again, I don't want to go too much into depth because we'll go through the whole semester a little bit. I gotta feed you one spoon at a time. Just remember that you don't dimension like crazy. Everything has a reason for dimensioning. Do not dimension on a two or from rough surfaces. Always attempt to dimension from a finished surface. Let me explain you why. Let's see if I can bring this back. Let's suppose that I have a part that I send it to be manufactured, and I don't know, maybe somebody that never manufactured in his life come up and gives me a part that looks like this. And again, I'm exaggerating for a reason. Okay? And then I tell you, hey, tell me how high this part is. And then somebody goes and it's like, oh, I'm gonna get a caliper. And again, if you never use a caliper, don't worry, I'll show you how to use calipers later. So they're gonna be like, oh, I wanna measure from here to here. Or maybe I should measure from here to there. Or maybe I should measure from here to here. Or maybe I should measure from here to here. Or where do I measure from, right? Do I measure from here to here? How do I dimension the height? Because my part is not perfect. It lives in a non-perfect world. The surface finish is different. The machining operation that you do is different. Maybe it has not been machined. Maybe I just got a piece of ingot, or maybe it's just a piece of hot raw material that I went and I bought, right? And this part is going to be part of a function. And if that's going to be the function, say this part right here is going to be made on top of something else. Let's say this little plate is going to sit in here, right? On the bottom of it. So it has a functional relationship with this other part. And since it has a functional relationship, might as well define the functional relationship by establishing a nice surface so it can sit on top of this. So instead of me putting it doesn't rock back and forth, right? And the way you do it is you flatten the back of the bottom of the part. And there are symbols that tell you that, which we'll learn later, right? After I have taken care of the part and I try to do my best to take care of it, it will look something like this. It will look something like that. It's called like this. And then again, I took care of the bottom, right? That's why I manufacture it, right? It's much better, nicer surface finish. And at this point of time, it has a better relationship between assembled components. And I can measure from here, let's call it from here to there, and from here to there. What is this region? This is where I told you guys the tolerance. This is the leeway that you give to the manufacturer. I can make it as small as this and as big as that. When you make it, you better fall within those limits. Let's call it 1. Let's call it 1.00 plus minus 0.15. You better, when you make it, it cannot be bigger than 150,000 and it cannot be smaller than 150,000, right? Your part needs to live somewhere in the middle. And you accomplish this by taking care of the surface at mating, depending on the function, right? Hopefully that makes sense. Give complete dimensions so that manufacturing personnel do not have to interrupt their work to calculate otherwise or determine otherwise dimensions they need. Yes, you do not just go start dimensioning. You gotta give them everything they need. You don't want them to get things and start asking if time is money. You don't make them guess anything. Everything that when your drawings are done, they should contain all the information necessary for them to finish the work. Apply dimensions in the views where the shape of the part is shown most accurately. What do I mean with that? If I have a part let's do something really quick. I'm gonna make a part that looks like this. Let's go crazy. Let's put a hole in the middle. Let's put one hole here. Let's put one hole there. And let's put one hole here. I might as well one here. Right? If I were to make a hole, I can only make it where I could see the hole, so I can grab my drill and I can go near, right? I need to locate the bullseye, right? So if I want to see if I can do this really quick, so let's say the front view will look like this, and then it has, and I'm gonna hide the hidden line so we don't get confused, right? Let's say this looks like this, and it has one right here and one here, and then the side view, let's say it looks, sorry for the mess, it looks something like this. You have that one, you have that one, you have that one, you have a hole right here, right? Okay, so now if I were to look at that hole, in order for me to grab my drill, I have to be able to see it. So if I'm going to dimension that hole, I need to dimension where I could see it, right? So the hole in the front view, because you see it in the front. This other hole gets to be dimensioned on the top view because the bullseye is on the top of the part. The same thing with that one, right? It has to be there. And if I were to, and again, this guy is the top view, top view, top view, top view. And then this hole lives on the side view. Why? Because I can't have to put my drill and work this way. So I can only see it on the side view. And yes, you have a bunch of hidden lines all over the place where you can also see that hole from the top in the front view. And you might also see it on the side view. But you don't know dimension to hidden features because you cannot see them. So the holes, where the holes are, the thickness, where you can see the thickness. The thickness, where you can see the thickness. In here, I don't know if that line represents a thickness. Let's get the isometric, right? Do you know if that is a thickness? I don't know. It could be like a rounded, maybe even slanted. This guy could have been like that, you know? Could have been like that. If I did not show you the isometric, you wouldn't know it, right? So you don't know if that is a thickness or not a thickness. You gotta go to the view where you can see a thickness. Hopefully that makes sense. Apply the dimensions in the views where the shape of the part is shown more accurately. Apply the dimension on those views where the part being dimensioned appears a true size and a true shape. Same concept, right? You dimension where the features are. You put the holes where the holes are. You put the notches where the notches are. You put the thickness where the thickness is. You put the slots where the slots are. You put the chamfers where the chamfers are. Do not dimension to hidden lines. Yes, if you cannot see it, how are you going to dimension it? Oh, next. Avoid crossing extension lines with dimension lines. What does that mean? Okay, let's get a little bit of nomenclature so you guys can see the difference. This line right here is called an extension line. That's an extension line. This guy's an extension line. That is an extension line, right? And if you guys were to look at it, and here I put the big one red for a reason, but if you guys were to look at that, there's a little gap on the extension line. Should be a gap. That gap should be between 1/16 to 1/8 of an inch. Okay. What I'm trying to say, do not cross dimensions. That means if I were to have this case, right? You don't do this. You don't go and grab that dimension, be like, oh, I'm going to grab that dimension and I'm going to put it over here. Let's put it there. No, because as soon as you do that, guess what? You're crossing things. See all this crossing that happened because I didn't decide to put it here and I put it over here. So that causes mistakes. It kind of like doesn't allow you to look at your design intent. So do not cross things. Clearly dimension and annotate all features. Move away from the part. As you guys will notice, this drawing has no dimensions inside of it. You guys also will notice that it doesn't have all the views because remember, one of the rules is you put the views that are necessary for design intent. That's it. So I don't have a side view, so I don't need it. The dimensions are far away. In fact, there's a certain spacing that you need to have. This spacing between the part to the first line should be about 3/8 of an inch. If I see your dimensions really close to the part, they're wrong. You need to move away from the part, nothing inside of the part. Do not apply a complete chain of detailed dimensions, omit the last one, or indicate that the last dimension of the chain is a reference dimension. What do I mean with that? If I were to have a part that has a feature, let's say that looks like this, right? And let's say that if I were to go to the top view, somewhere in there, I went and I give you this dimension. So give you this dimension. Obviously, the resolution for my calculator, so it takes it. And then somewhere over here, a guy say, you know what, I'm gonna come and I'm gonna give that dimension, and then I'm gonna give that dimension. Right? People that don't listen to me. And then somewhere on the note says notes, unless otherwise specified, for all linear dimensions plus and minus 0.015, 15 thousandths of an inch. So then the manufacturer goes and he's like, okay, so it seems to me that I'm gonna do this slot, and that is a slot is plus minus 15,000, plus minus 15,000, plus minus 15,000, plus minus 15,000. So when you given the three dimensions in a row, that's 15, 30, 45 thousandths. From here to there is telling me that I have plus minus 45 thousandths. While the one on the top is telling me that I have 15 thousandths. So which one do I follow? The manufacturer guy will be like, okay, so that you are freaking confusing me. Because you are telling me that all dimensions have 15 thousandths. You are telling me that that one should be 45 thousandths. Well, that one should be 50 thousandths. Which one do I do? So be aware that when you put a dimension, it needs to grasp the feature, and it should not be double dimension anywhere, because double tolerances would happen. An inspection person will cry at you, and your design team will get mad at you. And if they did 100 million parts wrong, it's all going to fall on you. Avoid placing dimensions on the part itself. Yes, move away from the part. Always place dimension lines uniformly throughout the drawing. So yeah, the spacing between the S1 and that one should be kind of like, I'm not going to measure them, right? But they have to be like uniform. It has to be clean. Do your best to make it clean and uniform. There's actually a certain spacing we want to talk about in just a second, but just try to keep things uniform. Never use a line that constitutes a portion of a drawing of a part as a dimension line. For example, let's say, oh, you know what? I want to dimension the whole location to that surface. Oh, you know what? I'm going to go and I'm going to put it right here. No, man, no, don't do this. Don't use that guy. Move away from the part. Nothing inside of the part. Avoid crossing dimension lines whenever it's possible. Yeah, that is a thing. Dimension lines are this. You guys don't know what the dimension line. This one on the side are called extension lines. These guys are called dimension lines. In general, you do not cross things. As you guys could see, things are nice, well spaced. Everything decides what the feature is, and it's supposed to be in the place where it's supposed to go. And again, I think it will make a little bit more sense when we actually do one example in class. I just want to let you guys know that you just don't put dimensions, you want to put dimensions. That's why we're having a whole lecture just doing it correctly. So hopefully by the end of the class, you'll know how to do it correctly. We have a bunch of lines, as I previously told you. But basically, we have the thick and the thin. And you guys have noticed that I'm really emphasizing this. Why? Because I'm part of the standard. You just don't go and say, I'm going to make everything thick. Everything thin. Then it's thick and thin. And you guys could go there, different type of lines. We talk about visible lines or object lines. We have talked about hidden lines. We didn't do section lining, but we're going to do them. We talk about center lines. We talk about center marks. We are going to do dimension lines and extension lines. In general, everything that you will see and they are visible will be solid, as you see visible with your eye. Edges are solid. Whole edges are solid. Anything that is not visible to the eye will be most likely thin. There are usually exceptions, but most of it that's the case. This is what I was telling you guys. Things are supposed to be where they're supposed to be. You guys will notice that when you go and you put my extension lines, there's a little gap right there. There is a little gap right there. There is a little gap right there. Where's the problem here? This guy decided to cross. I could have gotten this dimension and I could have put it in the view next door. So you know what? I want to dimension the height on the other view. Boom, boom. And that way I don't cross. So you do not cross extension lines. You do not cross dimension lines. You do the best to avoid it. The spacing. You guys will notice you have a dimension line. Again, the dimension line is this one, right? You dimension arrows. There should be a gap between the part, and I previously told you it's about 3 inches on each. The consecutively after that, you will have a dimension of 1/4 of an inch minimum. In other words, is there not really a standard to say, oh, you gotta have a quarter. You can make it bigger as long as things are uniform. Uh, when you make a leader, the leader needs to be between. You don't make a leader that is horizontal. You don't make a leader that is vertical. You make a leader that is between 30 to 45 degrees. You can make one leader that looks like that. You can make a leader that looks like that. Now, when you are calling out a hole, your arrow needs to be pointing towards the center of the hole. You see, it's towards the center of the hole. Don't go and give me a call out like this. This is wrong. You gotta go towards the center and away from the center. Boom, just like that. We talked about this before, right? The spacing, the overhang. When you go, you have your extension line. Your extension line should protrude outside of the part, but about an eighth of an inch. So the little gap here again is between 1/60 to 1/8 of an inch. The spacing is at 3/8. Consecutively after that is between a quarter and more. The overhang is about an eighth of an inch. When you have your callouts, the little distance right here should be about an eighth of an inch. I've seen people that go and they give me a shoulder that looks like this, and then they put a diameter or something like that. This distance of the shoulder should be about 1/8 of an inch. Okay, and I think I just did 2, 4, 5, 6, about 6 of them. It took an hour just on a few rules, but we got more rules to go, guys. So don't worry about it. I think what I'm gonna do next time we meet, it's gonna be next week. I'll do one of the assignments with you, one of the homework number 6. And you guys pay a lot of attention on how I do it, so you can do the next one, okay? And again, follow these rules because we're gonna be dimensioning a lot of drawings. You need to understand how to dimension properly because you guys are gonna have a midterm, right? So pay attention and give you a bunch of examples, and hopefully, somewhere in the midterm you'll understand the rules, so you'll be okay for your midterm. Let me stop the share. Let me stop the recording. Let me stop it. Okay, I'm gonna do my best to try to explain you how to dimension properly. I think this is one of the parts that my students get the most red marks. Believe me, I really try. But when I want to give you guys quizzes and exams and assignments, and it's harder for me because I need to mark it. So imagine everything full with red, it's horrible. It's not work for me. So, I explain you guys, I want you guys to stop me if you feel like I'm going too fast. Or if you need a clarification somewhere, let me know. Thumbs up? Okay. So, you guys have a block. Is this the same one? No. Okay, so you guys took all the blocks. If you don't have the blocks that I have here, don't worry about it. It should be the same concept, right? In fact, my block doesn't look like yours, but it should be the same concept. When you actually start working on this assignment, you want to grab one block at a time. And if you don't have one of those blocks, you don't have this one or this one, just grab a block and drop it. Okay? Right. So, in case I'm going to do this one, and in case you're going to do your own, right? Let's read the assignment really quick. Your company has been given the chance to take over the manufacture of 2 high-volume plastic parts called the wedge block and the fixture block for the Borderboard Corporation. Your assignment is as follows: make hand-drawn proportional orthographic sketches of each of the part on engineering computation paper. Orient the paper in landscape, so it looks like this, as in the first assignment. Include only those views required for dimensioning. Only those views. Leave plenty of space between 1 to 2 inches around the views for dimensioning. So a lot of space, plenty. Arrange the views based on the convention that the isometric views given below show the front, the top, and the right side views. Before measuring the part, place the hand-drawn extension and dimension lines in the leaders on the views for all necessary dimensions. All dimensions should be baseline, using the bottom, the back, and the left sides of the part. Hints for number of dimensions for each part are given on the back of this page. Okay. Using the scale of 1/16 of an inch. So here I have a bunch of rulers, in case you guys need one. These rulers are for here. You want to use them, you guys are welcome, but you don't take it home. And I'm telling you because you see this one? It used to have like 60, all the way to the top. And people started taking this home. So it's not for you to take home. So you guys are going to use a ruler. You're going to record the dimensions to 2 decimal places, equivalent to the nearest 1/16 of an inch. So how are you going to do this? Who has a cheat sheet? You guys have a cheat sheet? Ash? I gave you a cheat sheet somewhere, right? The one that says cheat sheet. Who has a cheat sheet that I can use? Can I let borrow the cheat sheet? Nobody brings cheat sheet? There we go. Thank you. Okay. Just remember I give to you, okay? Remind me. Okay, so if you guys open your cheat sheet, which if you don't bring your cheat sheet, you should be bringing your cheat sheet every day. Somewhere in your cheat sheet, it tells you your fraction to 2 decimal equivalent, 3 decimal equivalent, and exact dimension. So now keep in mind that this is a little bit different. It's not just regular. And tell me why do you run it like this? I don't know. You should ask the mechanical engineer that came up with this rule. For example, in your regular, you will say that 1/8 is 0.1250. Yes. And in 3 decimal places will be 0.125. But in 2 decimal places will be 0.12. Why not 0.13? I don't know. That's why I give you the cheat sheet. Okay? So you're gonna look at your fraction when you measure with your ruler. You're gonna go here and then you're gonna say, oh, I'm doing the 2 decimal places. Boom. That's the one that I should be putting in there. Thumbs up? Yes? Okay. Alright. So just so you know, and I'm gonna keep this for a little bit, okay? The number should be about 1/8 of an inch. 0.125. So my ruler is this one, so about 1/8 of an inch will be located there. Which is about the size of your text that what you see right now in the paper. This is about 1/8 of an inch. Right? All of your text, everything that you put in your drawing should be uppercase, nothing lowercase. Use capital letters, print the following notes on the drawing. 1/8 of an inch, right? Approximate scale. And we're going to talk about the scale in just a second. What scale are you going to use? Print your name, part, name, engineering 2. You will have 2 hours, 2 2-hour lab sessions to make all the measurements and create the 2 sketches. So I would do all the measurements during the lab time, and then I can take my time because you don't want to be dealing with not finding the blocks, right? You'll be like, oh shoot, I don't have those blocks. In this class, I came into. So you guys take the measurements, return the block. Okay. Create the 2 sketches, orthographic sketches fulfilling the following requirements will be turned to the instructors at the end of the lab session. On this day, no. I'm going to give you more time. I'm not too crazy. What is this do? February 11 already. 2 gone, right? The sketches will be worth 50 points each, so the whole thing will be 30 points. Neatness is critical. Okay. Thumbs up. Let's say I'm Ash. Like, oh shit, man. I gotta do this block. This is a different one, right? Yep. I gotta do this block. And again, this is the point. This is the point where you guys pay attention. Okay. I'm like, oh shoot, I gotta do this, and I gotta dimension it. Okay, so let's see. This is my engineering paper, right? Want to see my engineering paper? And you're like, oh shoot. Okay, so first I want to know what's my front view, right? It's like, so in the case of your assignment, the front view is this one. That's the front. That's the front view, right? Which means if you were to look at your parts, all of them, this is top, front, and side view. Thumbs up. Yes? Okay. So you're going like, oh man, I need to dimension this. I know that this is the front view. Oh, you know what? You can just trace it. Oh, yes, man. I'm going to come over here. And then I'm going to come over here. And I'm going to make them straight, right? And then I'm gonna put a top view somewhere here. Boom, 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 boom. Easy peasy. Professor Scalona doesn't know my smartness. Let's put some dimensions. Believe me, by the time you're done, your dimension will not fit. You gotta scale this one down. And we haven't done the dimensions, that's why I'm doing it. To show you, you gotta shrink things down. Yes? And the way you shrink things down is by, I think we talked about this before briefly. So, you're gonna have in your scale, most likely you have seen a full scale. Full scale. And you might also have seen something that when they go and they call it half scale. Or that sometimes they call it even quarter scale. Or sometimes you have seen 1 inch, something that looks like this, right? Or a poncho one like this. Many of them, right? What does it mean? If I were to look at on the drawing and I were to put something that looks like this guy represents the paper and the one represents the real life. Okay? Paper and real life. If I tell you I want a full scale, that's telling me that my paper and my real life are both the same. Just like the sketch that I did before, which I don't even know what it is. Right? If I tell you that I'm doing a half scale, you write it like this. What does that mean? 1 inch on the paper is 2 inches in real life. I have gotten the real life and I have shrunk it by half, such that 1 inch on the paper represents 2 inches in real life. Does that make sense? What do you think will happen if I put a quarter? What would I write here? 1 to 4, exactly. 1 inch on the paper represents 4 inches in real life. That's all it means. Okay. Now, before you start, let's start again. I'm like, okay, so shoot, man. How do I put this, you know? You come over here and you're like, okay, so for sure I cannot do a full scale. That's way too big. Right? Maybe I can do half scale. Yes. That means I am going to multiply every dimension by a half. Yes. And if I were to have a 3/4 scale, I will have and I multiply every dimension by 3/4. For example, let's say that I want to do a half scale with this. What's up? I will go somewhere on a sketch paper. We'll say, you know what? I'm going to make it a half scale. Okay, so I'm going to come over here. That will be my top. That will be my front. That will be my side. What's up? Top, front, and side view. I have my drawing area. And I'm going to use 1 to 2 scale. So I need to know the size of my box. This is the real. Let's call it the real life. And let's call this guy the shrink life, the shrink one. Right? This is the paper one. Yes? Paper one. Okay, so I go and I grab my ruler and something really quick. I measure, and this guy seems to me it is 5 1/4. And the height, it seems to me, is 2 1/4. And the depth, it seems to me, is 3 inches. So what do I do with these dimensions? I'm multiplying by half to shrink them to the half. So now I come over here and I multiply everything by this factor, 1 to 2. Right? So that means that 3 inches will become 1 1/2. That means that these 5 inches will be 2 1/2, and a quarter will be 2 5/8, right? Is that correct? 2 5/8. And then this guy will become 1 1/8, 1.125. It's just half, whatever you put in the calculator. Okay, now this guy will be able to fit in my paper, right? This is half of it. So I'm gonna go over those numbers: top, front, and side view. I'm gonna make this guy 2 5/8. I'm gonna make this guy 1 1/2. I'm gonna make this guy 1.125, and my depth 1.5. Boom. Where do I get these numbers? Is the shrinked version, so I can move it and have a space for me to put dimensions, right? So when you go somewhere in your paper and you write the scale, you will say that is 1 to 2. You just shrink it. And again, you can also shrink it 3/4. You go crazy, whichever you feel. I would say go either a half or 3/4. That's the easy one. Okay. Next, I know my paper size in terms of drawing area. Yes? Who has engineering paper? Can you give me one? Okay. Engineering paper drawing area looks like this. Let's turn on the light. If I were to look at the engineering paper, this is my drawing area, which seems to me is 10 inches by 7 inches. So from here to there, that's 10 inches. From here to there, that's 7 inches. And then I told you, you know what? Give it a lot of room because I want to make sure that you go and you put your dimensions. Now, I propose to you that before we even start, we find out how many dimensions we need. That way, we can put the most spacing where I need the most spacing. Yes or no? Right. Haven't done anything yet. We're just planning. It's all planning purposes. Let's go over here and let's put it on the side. So let's come up with something really quick that gives me my overall size. So I'm gonna start with my boxes, something like this, something like that. Let's put it something like this. Boom, 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 boom. And then the front seems to me it looks like this. And then the top one looks to me something like this. Right, and it seems to me that I have, oops, this one looks like about yay. But here I have a line, and here I have a circle, and another one somewhere there. And on the side view, I have this one there, this one there, somewhere here, somewhere there. And again, I only want to show the visible lines for now, right? That way I don't get confused when I tell you, you put your dimensions where the features are. I want to be able to see the features, and if it's hidden, you don't see the feature. Does that make sense? Okay, so let me make it a little bit darker so we can start. And again, this is just overall something quick because you're just gonna use it to represent what you wanna do, right? Okay, so somewhere in your assignment, you probably heard something that says all dimensions should be baselined from the bottom, the back, the left side of the datum as datums. Okay, what do I mean? When you go, you guys graph a point in your math class. They give you an X and a Y and a Z. Yes? Okay. So when they don't give it to us, we have to make up, especially as we are the designer, we have to come up with a coordinate system. So the same thing happens when you manufacture things. When you go and you define the datums, you define them based on function. Right? So let's say that I come and I say, this block is going to sit on top of something. This is my datum. Not my part itself. It is what is made into. For example, my part will be imperfect. If I were to look at the bottom of the part, it might look like this. Yes? But what I care is that once it sits on the part as the bottom of it. And I dimension from the part, most likely because I want to, I don't know, it depends on the function in reality, right? But it goes from the bottom to the top. You see? From the bottom to the top. Because I put stuff in the table. Yes? And let's say that this part is going to sit against this wall. And maybe there is something here on the back. It's going to be nice and snuggy right there on the corner. You see it? Okay. So let's start with the bottom. I give you guys data so you don't have to actually come up with them. I told you bottom, left, and back. So what does that mean? Let's make my box really quick. So it looks like this. Go back, boom, boom, boom. Oh, by the way, if when I'm done, if you guys want to take a picture of this, you guys are welcome. You guys got Discord. You guys also welcome to post it in Discord, right? Yes, Discord. Do you guys have a Discord for this? Not yet. You guys will need it. So let's come over here. Let's say that one looks like that, something like this, something like that. Say somewhere here, somewhere there, somewhere here, somewhere there, something like that. And you have a hole here and another hole there. Right. This is I'm just representing this guy over here, right? So yeah, it helps me scratch on it. That's why I did it really quick. Okay. So if I were to come over here, I have my top, my front, and my side view. Yes. And I told you the bottom. Where do I see the bottom? This is the bottom, right? By the way, that's the bottom. Yes. It's the bottom. And the bottom I will see it on the bottom. So this is the bottom. Yes. And if I were to graph the bottom will look like that. Let's put an axis here, and let's put another axis here. Yes? And let's call this guy my 0,0. Right? Are we good? The bottom? Okay. I'm going to go from the bottom to the top. Where do I see the bottom? Well, I said it's on the front view and on the side view, and will look like a line, and it will be this one. and it will be this one. Yes? Yes? So I go from the bottom to the top. The first thing that I will see is that feature. What is that feature? That face, isn't it? Is that face? Is this face as I went from the bottom to the top? That's the first feature I see. When I tell you guys, you need to place it on the views where the feature belong, I need to be able to see the feature. Here you see thickness, yeah? Pretty good. Pretty good. If I were to manufacture this guy, most likely I will start with a block. Yes? And then I will go to the side view and I will take away that chunk. Most likely I will have a mill, flat mill, and I will go down and it will be take away the material, right? But most likely I will take away that chunk, which I will make it look like this. Yes, that will be my first operation. Done. Also, it seems to me that here I got another notch, right? See the notch? So most likely after that, I will go down and I will take away the other one. Right, so I went to the top and I will go sideways with my flat nail and I start going like this. Get rid of it, right? And then eventually I will go with my drill somewhere there and done. Yes, and I'm done. All right. So you guys will notice that my thickness, I noticed it here because when I was, and you guys will see it, right? Thickness, you can squeeze on it. And I also, this is the part where I go with my flat end mill and I go, right, to the height that I want. So the dimension goes where I can see it. Guess what? Where I can see it? I see it in this view. I want to know how much depth and it also can touch the thickness. It doesn't go here. Does that make sense? Yes? You put the thickness where you can see the thickness. Let's go again. Let's go up. New. The next thing is the height. Oh, the beauty of it is that the height you can see it on both views, right? So this is your judgment. Put it. Okay. Where do I want to put it? On the left or on the right? In my case, I want to put it on the left. Okay. Let's say I want to put it from here to there. Boom. Bueno. All right. So I'm done with the bottom. Check. I told you guys also do the left. Where do I see the left? It's two different color. Let's do orange. Let's do green. Okay, so green. No one. Let's do orange. That one is the what? That's the left, which represents this plane right here. This is the left plane. Yes, if what's happening? You are building a coordinate system. Yes. So this is my left, which is this one. And as I did before, I went from the bottom to the top. I saw the thickness, I saw the height. Now I'm going to go from the left and move towards the right. Okay? I'm going to go from here and I'm going to look at each of those features. Boom. That's the first feature I see. You are like, Professor Corona, why did you put it on the bottom? Because that's where I can see the thickness. That's where the notch occurred. That's how it got manufactured. Yes? Thumbs up? Next one. Boom. Bullseye, center lines, right? To the bullseye. Boom. Why did I put it on the top? Oh, because that's where you make the hole. You put it on the hole where it goes so you can know where it is. Boom, boom, boom. The next one goes here. Why did you put it here? Oh, because this is where my end mill comes and I can see the notch here. I cannot see it here. Yes or yes? So it goes here. The next one. Boom, 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 boom. The hole. And there's a reason why I don't put the hidden lines because I don't want you to measure to hidden features. If you don't see them, you cannot measure to them. So it goes to the top, right? Oh, Professor, why didn't I put it down? Oh, because there is no space, man. Okay. So I put it on the top. Say from there to there. Boom, 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 boom. What's it go on the top or the bottom? Top or front? The front, yes. Okay. You guys are probably finding out what is the place that I should go. Why didn't I put it down? Because I'm crossing the part. You try to avoid crossing the part as much as possible. So you guys probably will notice that when I actually do it for reals, I'm actually gonna have to ensure that I have a space in the center, because that's where it's gonna be the most crowded portion. So I can go boom, 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 width. What do I put it with? Well, I can put it on the top, I can put it on the bottom. Yes? Yeah. Where do you guys want to put it? Top or bottom? I mean top or front? Let's put it on the top. From here to there. And you can do both, by the way. Okay, so we are bottom, we are left. Let's go the last one. Where's my colors? Let's do purple. Purple is this one. This one is the back. And when I create my back, this is my back. Probably I should also label the other one. Let's call this guy the left. Let's call this one the bottom. Let's call this guy the bottom. Bottom. Let's call this guy the left. And the left. And we're doing purple right now. So the purple will be the back. So this is back. And this one is back. Back and back. And in real life will be this one, that one, that one, and that one, which will be my back. Yes or yes? No, the colors are not that great, but it's the back, the back, the back, the back, the back. Yes or yes? Right. Now, the same way that I went from the bottom to the top, from the left to the right, now I have to go from the back to the front. Now, this is the back, this is the front. This is the back, this is the front. This is the back, this is the front. Yes? Now, unluckily, I cannot do it like before, like this and like this. I'm going to have to get me a different ruler so I can do it. And I'm going to do it at the same time, because I got to go from the back to the front at the same time. So I go from here. The first feature that I see, I don't even see it. That hole is hidden. Yes? So where do I put it? Where I could see it, right? This is the back. Yes? I went from the back to the front. As I moved from the back towards the front, the first thing that happened was the hole. In the side view, I cannot see nothing, right? It's gone. I can only see it from my top view as I go this way. Yes? All right, so from the back to the front. First feature. Boom. Boom. Where's that one? It's this one, right? Is that one, right? Which is this one. Where can I see the notch? Here. Yes? Here. So it goes from here to there. Boom. The hole I'm not going to ask you. I'm going to assume that you guys know it goes here, right? So, which, want to say from here to there. Right? From the back to the front. You guys will ask me, okay, Professor, why did you put this one and then you put this one? It seems to me they are on the same. They are different features. Okay? Different features, different dimensions. When you manufacture something, this will have its own tolerance, its own leeway for fabrication, and this guy will have its own leeway for fabrication. What's up? Right. Next one. Bam, 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 bam. Depth. Yes? The depth. Boom, boom, boom. Question. Did I use this guy? Boom. Only the views necessary to require to convey your design intent and no more. You don't need the view, you don't put the view. Thumbs up? Okay. Now, question. Do I have any fillets? Fillets, what's a fillet? Okay, fillet. Have you guys ever seen an angle? It looks like an angle like this. I think you guys did an angle in one of your assignments that looked like that, right? I don't know, did you? Yeah, it was one of your assignments that it was horribly. Nobody put threads and callouts. And... Yes? Okay. You guys seen this angle before, right? This guy here, which is kind of like a roundy little thing, this guy is a fillet. Fillet. And then this roundy little thing right here is called a round. Question, do I have fillets? No. Straight, right? No fillet. Any rounds? No rounds. Any holes? Check. I gotta call them out. So go towards the center of the part, move away, boom, boom. I got two of them, so 2 times diameter. The size of the hole, I don't know, 3/4, let's call it 0.25, 0.75. Both of them I go through, boom. Does that make sense? Okay. What dimensions do I put here? Well, I shrink everything by 2. Maybe I should multiply everything by half. No. When you go and you make a drawing, if I make you a drawing of a house, and you measure this with your ruler and measure 10 inches, does it mean that you are going to build a house 10 inches? No. These are the real dimensions. Okay? So you go for reals, and you're like, oh shit, what's it going to be? I'm going to grab my ruler. And if you remember, it was 5 1/4. So 5.25. And you get all of the other ones, right? All the other dimensions. Pum, 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 pum. How many decimal places? 2 decimal places. You have a cheat sheet. So, okay. From the bottom to the top, from the left to the right, from the back to the front. Fillets, rounds, holes. You dimension where the features are, where the features belong. You do not cross the part. No dimensions inside of the part. None. There is a spacing between everything. Now, you guys, we haven't finished the lecture, right? But there's still more rules to go. When you make an arrow, your arrow is a 1, 2, 3. 1, 2, 3. This is 1, 1, 2, 3. Your arrow connects. Boom. So it is pointy arrow. This is not an arrow. This is not an arrow. It is a 1 to 3 ratio. What's up? When you dimension to a feature, say my feature is this one. You dimension to a feature, there should be a gap. These guys are called extension lines. Okay? My arrow, pointy, pointy. Let's call this guy 0.250. Right? No leading zeros. No zeros in the front. 2 decimal places. Pointy arrows. There should be a gap in here. This gap should be between 1/16 of an inch to about 1/8 of an inch. This extra protrusion after the dimension line should be about 1/8 of an inch. Your text should be about 1/8 of an inch. Stop. If I'm calling out a hole, say the hole looks like this. Let's make it darker. By the way, some of you guys don't dark the holes. The holes, I can see them, right? Look at that. There's a big old edge right there. So it's a visible line. I don't know why you guys don't put visible lines there, but now you guys know. It's visible. You can see it. Right? So I come over here, put my bullseye, right? Bullseye, bullseye, bullseye. And then I go towards the center, away from the center, make a line. And then I should have a shoulder. And then I have my little arrow, which is about 1 to 3. Yes? And I go and I give it, I don't know, let's say diameter 0.75 through. Okay. This gap from here to there, should be about 1/8 of an inch. Don't do this. Don't do this. This angle is between 30 degrees to 60 degrees, nothing more. You don't put the arrows like this, you don't put the arrows like this. There should always be a little shoulder. Don't go and say, oh, I'm going to put an arrow like this and I'm going to call this guy like that. No. So, believe me, there's so many rules. You guys take more classes with me, you probably will learn. We don't have time. You learn it through the use of them. We're going to go through all of them in the lecture. Most likely we will finish hopefully tomorrow, right? And then make sure when you actually get to do it, you follow the rule. Okay. Okay. Arrows, spacing, hole callouts, big line weights, thicknesses, center marks, center lines, notes. Now we have a better idea of what we're going to do. Yes? And then when I go and I actually do it on the drawing, my drawing, I don't know, probably should find it. Let's see. There we go. This is not bueno, right? This was a full scale. This is my approximate mathematics, right? Which we were able to reduce it so I can center. Yes? And I know I have a better idea that it should look like this, which means that I need 1, 2, 3, 4. Oh, by the way, the spacing between the part to the first dimension line should be 3/8 of an inch, and consecutively should be at least 1/4 of an inch. Professor, what did you get all this? Crazy robot. They're not mine. They're based on the standard. I just know them. I use them all the time. Thumbs up? Okay. I should bring you the book so I can show you that I'm not lying. It's in there. But if you take my classes, that's why we're state champions and we're fifth in the nation. I'm so picky. Make them do it for real, right? Wait, boom, boom, boom. Okay. Okay, so you guys will notice that I have 1, 2, 3, 4. So most of the spacing is where? In the center. Also, you guys will notice that when I centered it, I don't need that one. So in reality, my spacing will be one view only. That makes sense? I want to give as much spacing on the center because that's where things are going to occur. So for this guy, I will give it at least two, yes. Okay, yeah, so I will first start with this one. I will start here. So let me see, where's your assignment? Let's take a look at it. Do I need the views? Let's test it. This is to be your thinking, right? Do I need the view? Let's go this way. So do I need this view to manufacture it? Well, I have an angle. And that angle will be most likely identified by knowing this distance, that distance. Yes? So I need that view, I need an angle. I need a W to get much close. Yes? So I need a side view. Boom. So you have to notice this a little harder. Right? So I need it. I need the 3 views for this one. So, look at that one. Then I need the front view. Boom. Well, I need it because I have like a notch here. See a notch? If I go to the top, I need this hole. If I go to the side, I need that hole. But yes, you guys are lucky. You guys get to keep the 3 views. So, again, you will think about it, okay, so do I need it? And again, why am I telling you this? Because you guys are going to be quizzed. From now on, we're going to do a bunch of dimensions. Your midterm is going to be based on dimensioning and modeling, right? So, you should know. So, usually what happens is that I mark the drawing so badly that it makes so much work for me that I just end up giving you the answer. In fact, if you guys were to look in Dropbox would say, do just like mine. What do you think I give you that? Because I don't want to flunk you. But I want you guys to learn from the do just like mine, so you do like mine and you learn how to do it properly. So when you go to the midterm, you got 10 examples that you did properly, hopefully. Right? Does that make sense? Okay. All right, so in case of you guys, I'm going to assume that now you should know what's going on, right? Next time when we meet, we'll wrap up the rules. Yes, wrap up the rules. And then we'll most likely start with 3D modeling. And that's it for hand drafting anymore. From the next, we finish the rules, and then from then on until the end of the semester will be 3D modeling. Thumbs up? Okay, you guys can continue. And again, thank you for the cheat sheet. Just come grab the cheat sheet.